All right, let's start. I know a few others are going to come on, but let's get started. I'm just going to work them. It's getting late, so don't have a lot of time on them. But it's a good refresher since the exam's on Thursday, pretty quick here. So the first one, the math is really simple on this first one. So it's more the verbiage. It's really not an essay question like the others. Those other two essay questions are quite massive, but you have more time on those, right? You have until next week on those. So this is somewhat of a mini essay question. The discussion's probably as important as the numbers. So the question here is, what are we asking about? We're asking about a triple B bond, and we're looking at 10-year bond. It's paying 100 basis point spread. And so we look at 10 years here in triple B, and we see this is the cumulative default rates. The cumulative default rates is 324. That doesn't mean you're going to lose 3.24%. It means over 10 years, you'll accumulate 3.24. So the average annual default is going to equal that. If you want to convert it to basis points, that's fine. I might do that. 324 basis points divided by 10 years, which equals 32.4 basis points per year versus the 100 basis point spread. But we're also recoveries average for triple B about 30%. You can see 30% for most other rating categories. So we can take so 32.4 times 1 minus 30%, because we're going to get 30% of our money back. So we're going to lose 70 on average every year. We'll lose 70% of 32.4 basis points. And when you do the math on that, you should get 22 point, you can rounding's fine, 22.7 versus our spread, 100 basis points. Therefore, the spread more than covers our expected average default losses of 22.7 basis points. So the spread, 100 basis points, more than covers. However, this does not include spread slash price slash market risk. That is the risk of price changes other than actual defaults. For example, spreads gap out in recessions, causing price losses even if the bond does not default. I talked about this when we were talking about paper one. Some banks, when they talk about credit risk, they include both the default risk and the spread risk. Some banks, when they talk about credit risk, they're only talking about default risk and they leave spread risk under price or market risk. So it depends on the company. The other issue you might bring up here, I think we talked about it quickly in class, is also spread risk is highly correlated to stock risk. Stocks fall, spreads gap out in recessions. So the correlation, diversification benefit is lower for corporate bonds than for treasuries, thus justifying additional spread. Now you have to put it in your own words. I'm going to keep this, so don't say it exactly like this. You got to write it too from memory, but put it in your own words. But I think that covers everything we talked about in class. Go back to your own notes in class and just see. All right, so there's that one question. The math is real simple. You just find the spread. I mean, you find the cumulative default divided by the 10, multiply by 1 minus recovery. That tells you on average, you're going to lose 22.7 basis points when you buy a triple B bond. Over the next 10 years, each year you'll average 22.7. But you're getting paid 100 every year. That's your spread every year. So you're more than covered for default risk, but there's other risk in here: spread risk, price risk, correlation, diversification. There's other risks that spread needs to cover. But most people believe corporate bonds really do more than compensate you for the risk, which is why a lot of bond investors just do not buy treasuries. They just don't think they're getting, they just think they're getting more than compensated. All right. If you have any questions, you'll just have to interrupt me because I'm going to keep going. So let's look at question 2. Question 2, a lot of math. I'm actually going to word the problem to cut back a little bit on the calculations, although I don't think it's bad for you to do these calculations because they're really, really important. And if you don't have this formula, absolutely no, if you just don't know it, it's not going to hurt you to have to calculate it a few times. So in this problem, the hedge fund is $10 million. They're looking at the add either A, B, or C, and they're going to move 30% to one of those managers. Your risk tolerance is 0.75%. Your boss has expressed the desire to reduce the fund's VAR below 500,000. We can see what it is right now when we calculate it. Or the current level we say is about 800,000. That helps you to make sure you're doing the math correctly. So which allocation you recommend and why? Don't forget the and why, the graph, and then this last question that can be almost anything. The first 2 questions will be pretty straightforward. So if we're going to do current and A, then we got a return that's going to equal 0.7 times current's return, 5.2%, plus 0.3 times current times A strategy, that's 5%. That gives us an expected return of 0.0514. And a risk is going to equal the square root of weight of current squared times the risk of current squared. And y'all, hopefully y'all got this formula down, plus the weight of A squared plus the risk of A squared times, plus 2 weight of current times weight of A times risk of current times risk of A times the correlation current and A. I'll take the square root of that. I'll type out the first one. I'm not going to do all of them. When you type out of it, you get the square root of 0.7 times 0.7 times the risk of A, or current, you can see is 5.4 times 0.054 times 0.054 plus 0.3 times 0.3 times A is 7%, 0.07 is 0.07 plus 2 times 0.7 times 0.3 times 0.5054 times 0.07. You take the square root of all of that, you should get 0.04677. Practice it on your calculators. Make sure you have it down. 0.4677. Current. And B, I'm not going to do all the math, but the return is going to be 70% of 5.2 plus 30% of 5.3, and that should give you 0.0523. And the risk is going to be 0.7 times the first part's exactly the same, then 0.3, but instead of 7%, we use 9%. Oh, I left out the last little part. How could y'all let me do that? I left off correlation. So let me do that again. 0.7 times 0.7 times a risk, 3, risk, 2 times 7 times 3 times 4 times 0.07, and then the correlation, 0.2. When you do that, you get 0.0467. So for B, you use the first part's exactly the same, then 0.3, but then you use 9%. And then the last part's the same, except for you use 9% and you use -0.1. When you do that, you should get 0.0442. And in current and C, your return should equal 70% times 5.2 plus 30% times 5.4. And that should get you 0.0526. And then the risk, the first part's exactly the same, 0.3 times, and now your risk is 5%. So use 5 instead of 7, 2.7, 0.3, 0.054, and then you use 5% here, and then you use 0.1 there. When you do that, you should get a risk 0.04204. You notice how I'm not using percents. I'm putting everything into decimals. I don't know if any of y'all worked it and got those answers. I don't know if anybody can confirm. Has anybody worked a problem in advance? No one's talking, so that's not a good sign. There's a lot of you out there. All right, I'm assuming those are the right answers. I've got it pre-coded here. So the last thing you want to do is do the vars. So the current var is going to equal the mean minus the number of standard deviations times the standard deviation. So that's going to equal, for them, the mean is 5.2. Minus, so how many standard deviations are there? So their risk tolerance is 0.75. .0075. So table value is going to equal 1 minus 0.0075. And so that's going to equal 0.9925. We go to the table and look for 9925. 9925 is right there. 2.43. So our table value is 2.43 standard deviations. So if we're looking for the var, it's going to be the mean minus the number of standard deviations, 2.43 times our standard deviation. Our standard deviation is 5.4. That gives us a var. Remember, we do it in absolute terms. It's going to come out as a negative number, but you type it as an absolute number. And then in dollars, it's going to equal 0.0792 times 10 million. That's going to equal 792,200. Then you do the same thing here. Your var here is going to equal your mean, 0.0514. Mean is your expected return, minus 2.43 times your risk, 0.04677. That's going to equal 0.0662 or 66622,492. Don't worry about rounding. So if you just say 622,000, that's good enough. You can go out 2 decimal places. So 622,000 is fine. On this one, the VAR is going to equal 0.0523 minus 2.43 times 0.0442. And that's going to equal 0.0551 or 551,082 or 551. And the last one, the VAR, going to equal 0.0526 minus 2.43 times 0.04204. That's going to equal 0.0496 or 495,537. So which one are you going to recommend? Well, what did she say she wanted? She wanted to reduce the VAR, but without harming return. So all of them do okay on returns. Their expected return before was 5 point. No, all of them. A doesn't work. So it reduces return. So we're going to strike that one. That's not good. B is good on return. So that's helpful. But risk not less. So you wanted our goal was 500,000. So that one didn't quite make it. You see where she says she wanted it below 500,000. So that one we can strike out. And on C, it's good on return. And good on risk. On VAR, below 500. Questions on that first part? Now you notice the VAR for the portfolio, we got 792. She says it was about 800. So we're in the ballpark, about 800,000. That is about 800,000. I'm not hearing any questions. So either y'all are all asleep or you got all this. Then on risk versus return, the graph, the key here is you're going to graph these numbers, but look at how she wants the graph. She wants the graph with bars as percents. So you're going to graph the current, which is 0.052 and 0.07. Then you're going to graph 0.0514 and 0.04677 current, and A, you're going to graph 0.0523 and 0.0442 current, and B, and then you're going to graph 0.0526 and 0.4204 current, and C. No, the VARs, excuse me. So someone should have stopped me. So I was seeing if anyone was paying attention. So you want to do it in VARs. So the VARs are 6,622. This VAR, wait, let me get it right. So this VAR was 792 for A. I mean, for the current, 792 for A. It was 622 for B. It was 551, and for C, it was 496. So I would graph the returns on the y-axis, risk VAR percent on the x-axis. I would draw a line across your starting point, which is 5.2%. And here I would draw a line at 0.05, which is the goal. So you graph all of that and you would have it. I can't actually show you that graph, but just graph those pieces. So draw a graph where you may start at 5.1% and maybe go by 2% increments, 5.1, 5.12%, 5.14, all the way up to 5.3, something like that. And then on the axis, maybe start at 4% and go at 410, 425, 450, just have that across, and then find those points. Be real careful as you draw. You might bring a ruler so you can get some lines in there and graph it out, and then show what your recommended is. What you're going to show is that the highest return is current with C. So all of them are above your starting point, and then you're going to show that only one of them is below your 5%, risk target. Hopefully I got all the right numbers. Any questions on that? So your worst thought's going to either be current in A. Current has the highest risk, but A has the lowest return. B and C are both superior to your current strategy and current in A. They're both superior. C is the obvious superior one because it has both the highest return and it gets you below that 5%. So it's the obvious solution. So no questions on that. I'll leave y'all to drawing the graph. All right. And then this last one, there's no table or anything for it other than, well, down here there is a table. So your boss has expressed, you just have to read the question and see what your boss is asking. And this really comes down to just incorporating what we talked about in class. So your boss is concerned about the reliability of correlation assumptions over time in different environments. We talked about that. Correlations are unstable depending on the environments. She's also concerned that all of these assumptions came during times where stocks and bonds were lowly correlated because there was not much inflation. And so you got this table, all of this table is during a time where we had very little inflation. So you can actually add that into your answer. But what you'll notice, C is what you like, but then you notice during the financial crisis of 2008, strategy C actually had the highest correlation. So even though its correlation is only 0.1 over time, during a crisis, its correlation was the highest of the three. So it actually provides the best diversification when you least need it during some really strong markets. I know this says through 2020, so you have COVID in there, but COVID was a big sell-off in March, April, but then the market recovered by the end of 2020. So a couple of issues here. During the crisis, C provided the least diversification. Secondly, we don't have any correlations during an inflationary period. So you could throw this whole thing out. Who knows what inflation would have done? It'd been nice if we'd had 2022 in here to be a look at that. So that's what you're looking at. It's really a comment. Sometimes the discussion would be about skewness. So you'll see certain strategies because remember up here, we're using a parametric value risk. Parametric value risk assumes wonderful symmetry, but some of these portfolios may have some skewing, either positively or negatively. I might give you something on skewing where you have to talk about the skewing. So who knows on this third question? The third question is where people tend to struggle a little bit. So most people do well on the first one. Some people struggle on the second one just because they're really horrible graph drawers. They just don't put much effort into it. I don't think it's because they're not capable. I think they're just like, for some reason, in a hurry. I guess they want to get out of the final as fast as possible. If you sit down and just are diligent about it, you should get full credit on B. And then C, it's just a matter of reading the question and thinking about what we talked about in class and seeing what you can do. I actually really love this question, which means I can't give it to you again because it'd be exactly the same question again. So I'll give you probably something different, but the third one, who knows what all combinations I could come up with. So that's it. That's what the two math problems are on the exam.